Module 5, Part 3, Dividing Complex Rational Expressions. This part only has one objective, and that is to divide complex rational expressions. For this objective, though, there's three goals to consider and steps, I guess you consider as you're working through this. The first is to be able to recognize what makes the expression complex. The next would be to be able to switch to a division problem and then multiply by the reciprocal. And then finally, to be able to cancel out like factors or reduce any whole numbers that might be left over as well. And so I'm going to take you through those steps and write them out a little clearer as we work through example 1. Now I'm going to do example 1, and then I'm going to ask you to do 2 through 6, and your goal should be the mastery 5 out of 5 for this part. So, number 1, to be able to recognize why this is complex, the first thing I would look at is that there seems to be a rational expression in the numerator and a rational expression in the denominator. So we're used to something like this, x minus 2 over 16 divided by x minus 4 over 4. We've seen division problems with rational expressions before, but never written in this format in number 1's case. And so what makes this complex is that there is a division bar or a fraction bar that is separating the two, and the way they've written this is that there's a rational expression in the numerator and a rational expression in the denominator. And so because that exists, that is why this is complex. It's not written in this format, it's written in its complex format. So the first step in being able to simplify a complex rational expression like this, and I'm sorry, that is why it's complex, because the numerator and denominator each contain a rational expression. So the first step, again, to simplify this, like the directions say, and state the excluded values, is to rewrite it as a division problem. So I'm going to put that. Rewrite as division. So I did that up here already. X minus 2 over 16 divided by x minus 4 over 4. All right, I rewrote as division. Now I need to, with any division problem, this division tells me I need to do my second step, multiply by reciprocal. So instead, I'm going to drop this side down. I didn't do anything with that. X minus 2 over 16 times 4 over x minus 4. Remember the reciprocal, I just flip them. And so instead of x minus 4 on top, it's now on the bottom. That concludes step 2. Now at step 3, again, we have to, after I consider, is there anything that can be factored? In this case, nothing can be factored. It's already down into its factored form. So from that then, because nothing needs to be factored, my step 3 is to state excluded values from factored form. It's already in factored form, so I just state excluded values. Remember, for excluded values, I look for factors in my denominator. X minus 4 is a factor. 16 is not a factor. 16 isn't a factor because it doesn't have a variable with it. It's just a number that stands alone. So all I can work with is x minus 4. Again, two ways to think about this. There's only one number that I put in for x here that if I do would give me 0 for this factor. And that number is x can't equal positive 4. Because if I put 4 into this x right here, 4 minus 4 is 0, and that can't exist in the denominator. So that x can't equal 4 there. So that is my excluded value. Now, finally, to simplify this in its fullest terms and finish out number 1, step 4 is to, I'm going to put cancel out factors / reduce whole numbers. At times there will be factors you can cancel out, and at other times there will be whole numbers you can reduce. So I need to go back to step 2 for this and look at factored form right here. There are no like factors. X minus 2 and x minus 4 are not the same. So all I can see that I can work with is this whole number 4 and this whole number 16. Now from that point then, let me rewrite this and clean this up and put the whole numbers first so it looks a little nicer. So please do this as well, and please get in the habit of writing like this, putting whole numbers before the binomial factor. Over 16 is x minus 4. Now, if you can visualize this then, this fraction, 4/16, can reduce. It reduces down to 1 over 4. Again, put that in your calculator or consider numbers that go into both, but you have to reduce it fully or simplify it fully so it reduces to 1 over 4. So this is the only case that reduces in this problem. It reduces to 1 over 4. X minus 2 is still on top. X minus 4 is on bottom. And x can't equal positive 4 from, again, this factor right here. And this is my final answer. So your final answer needs to include the simplified version or the fully reduced version and the excluded value. So again, step 4 will look different pending the actual complex rational expression that's given, but you have to consider, are there whole numbers to reduce or are there factors like can cancel out?